In the last few videos, we deployed our Spring Boot application to Azure Web App Service and connected the application to the Azure database for MySQL. As you can see, the deployed application returns this JSON message as a response to this API call. The developers are happy. But are we done? As we all know, life is unpredictable. For example, what if the database is offline? Or what if the Spring Boot application is down due to a defect? Or what if the application's performance degrades? Furthermore, what if system resources such as CPU, memory, or disk space is exhausted? The developers will not like those. But they do need to be alerted when such things happen. Being able to gain some insight into what is going on inside the deployed application is really, really important. The developers can then quickly take action to resolve those problems. The takeaway point here is that deployment is not the end of the journey. The running software needs to be monitored. I think a good analogy here is the dashboard of a car. As a driver, I need to constantly monitor the health of my vehicle. The car dashboard provides many health indicators, such as engine temperature, tire pressure, battery, brake, and so on. In software development, we also need a tool to tell us the current status of our application. Like, is it healthy or unhealthy? How much memory our application is using? Does the application have the correct configuration values? And so on. This becomes even more critical with microservices, where an application is arranged as a collection of small, loosely coupled, and independent services. Those services collaborate when handling requests. It is not uncommon that a single request may travel through multiple microservices to get the job done. If we don't have some kind of monitoring or observing mechanism, we will not know where things go wrong during the journey of a request. We should also regularly run health checks against all the microservices. What should we do? The solution is Spring Boot Actuator. Spring Boot Actuator provides many out-of-the-box production-ready features that monitor and interact with the Spring Boot application in production, gather various metrics, and understand traffic and the state of the database. Remember, it is critical to see inside of the live application while it is running in a production environment. For your information, an actuator in mechanical engineering context is a component that can be triggered by a signal and generate some movement or motion. That movement or motion is then used to control a system or perform a task. Spring Boot borrows this idea, and we can use Spring Boot Actuator to monitor and control our application. That's how we got this name, Actuator. I would like to point out another advantage of Spring Boot Actuator that many people may overlook. Besides monitoring the application's health and system resource usage, I call them machine-level metrics. Spring Boot Actuator enables software development team to create custom business-level metrics, which are collected in a production environment. Those business-level metrics data support the definition and instrumentation of the team's SLAs and SLOs. They also empower the team to make solid and informed decisions based on not hunches, but data. So first, let me show you a quick demo of Spring Boot Actuator in a production environment. This is our production website deployed on Microsoft Azure Web App Services. Let me show you how powerful Spring Boot Actuator is in this production site. In a nutshell, Spring Boot Actuator exposes many API endpoints to help monitor and manage the application. So for example, let's access the most popular actuator endpoint, actuator/health. So all the endpoints start with /actuator. So press enter. Okay, as you can see, the health endpoint shows the overall health status. It is up, very good. It also shows a summary of several health checks for its components. For example, database, disk space, liveness, ping, readiness, and usable memory. They're all up. If one of them becomes down, then the overall status of our application will also be down. Next, let's access the second important endpoint, actuator info. As you can see, this endpoint provides application information. For example, the name, description, version, author, and the links of this app. It also shows the Git information, also the build information, the Java and operating system information. The third endpoint I want to show you is actuator metrics. Spring Boot Actuator is collecting all of those metrics automatically for us. We have JDBC, JVM, Spring Data Repository, Spring Security, CPU, Load, Tomcat, and so on. And we can access one of them by appending this metric name to actuator metrics, like here. As you can see, it took more than 2 minutes to start my Spring Boot application. But thanks to the staging environment offered by Microsoft Azure, that 2 minutes were actually on the staging site, not the production site. Okay, let me show you one more. Actuator environment. This one shows the active profiles and various properties of the current Spring Boot application. As you can see, now we're on prod profile, port 80, and here are a list of active properties. Oh, by the way, this actuator endpoint shows all the available endpoints for this application. So in this video, let's get familiar with the various production-ready endpoints that come with Spring Boot Actuator, configure them, customize some endpoints, and create our own custom endpoint. In the next video, we'll use some professional tools to analyze the data collected from the Spring Boot Actuator. For example, visualizing the metrics and traces, and triggering alerts when bad things happen. Next, let's implement what I just showed you. Let's go to IntelliJ. Let's install the Spring Boot Actuator in our project that we have used throughout the tutorial. Since we will modify our application, we'd better start with a new branch. Git branch Spring Boot Actuator. Git switch. Okay. Let's go to the pom.xml file. Okay, first, let's bump up the Spring Boot version to 3.2.0. Spring Boot 3.2.0 brings in some nice improvements to the actuator. Then we also need to bump up the Spring Cloud Azure version. So right now it's 5.6.0, and let's change it to 5.7.0. Otherwise, Spring Cloud Azure will complain. Okay, so make sure we load Maven changes. Since we upgraded our Spring Boot, let's run some local tests to make sure everything is okay. Okay, everything's okay. Next, let's go ahead and add in the actuator dependency. Spring Boot starter actuator. And make sure here we load Maven changes. Now let's open the Maven panel. And I want to show you the dependencies we just brought in right here. In Spring Boot starter actuator, there are two important dependencies: actuator auto-configure and micrometer. Thanks to the auto-configure feature, we can get many useful endpoints out of the box. Micrometer is Spring Boot's application metrics collector. I will show you how to use that when we talk about the metrics endpoint. Okay? Let's go ahead and start our application. All right. Now let's look at the console. Here it says exposing one endpoint beneath base path / actuator. So it looks like by default, there's only one exposed endpoint. And let's take a look. Let's go to the browser, localhost, actuator, and press enter. So it's John 1, 2, 3, 4, 5, 6. If you're using Google Chrome, I highly recommend you install a Chrome JSON formatter extension. As you can see, this /actuator endpoint returns something called a discovery page with links to all the available endpoints. There is a fancy name for this RESTful practice, hypermedia as the engine of application state, or HATEOAS. Just think of it as a discovery page with links to all the available endpoints. Let's try to access the health endpoint. Localhost actuator / health. It returns a pretty boring status up message. Not a lot of information. We'll fix that later on. But the good thing is we know our Spring Boot application is healthy because it is up. Recall that in the actuator demo on the production site, I showed a couple of endpoints. It turns out that there are many. This is the official document of Spring Boot Actuator. I included a link in the description of this video. As you can see, in the endpoints section, there are many useful endpoints. The way to access those endpoints is /actuator /endpoint ID. You have seen the demo of health, info, metrics, and environment endpoints. Later on, I will show you more endpoints like beans, configprops, httpexchanges, loggers, mappings, heapdump, and Prometheus. I would like to make a comment here. All the features in the actuator are production ready. That means they're not only supposed to be used during development, we can benefit from those features in a production environment. Okay, let's try to access those endpoints. Let's start with the environment endpoint. What's going on? Why do I get a 404 error? Oh, by the way, if you follow along with me, you may get a different JSON response, like this. This response code and message are not correct, so I fixed it offline by first adding a new exception handler in the exception handler advice class, and second, by adding a configuration in the application.yml file. In Spring Boot 3.2, the configuration in the application.yml file is optional. I included a link to that Git commit in the description of this video. Don't worry, it's not a big deal. You don't have to fix it. This is just for your information. Then why do I get a 404 error? It turns out that by default, only the health endpoint is exposed over HTTP, since endpoints may contain sensitive information, and the web is not considered as secure. If you look at /actuator, and that tells you the exposed endpoints. As I said, by default, only health is exposed. So let's explicitly expose more endpoints. We need to add a configuration property in the application.yml file. So let's go there. So let's come down here and add a new configuration property. Management, endpoints, web, exposure, include. And we're going to expose health, comma, info, comma, metrics. So those are the IDs of the endpoints. Environment, beans, configprops, heapdump, httpexchanges, loggers, mappings. Just make sure you separate them by comma. Those are the endpoints I want to show you in this video. And in this case, we only want to expose those endpoints. And of course, you can simply put, let me show you a different way to do it. Let me cut this, and you can put a wildcard, asterisk. Now this means we're going to expose all the endpoints, everything you saw in that Spring Boot official documentation. Now, what if you want to exclude something? That's also fine. So come down here and write exclude, for example, env, comma, beans. So this means we expose everything over HTTP except the environment and beans endpoints. I prefer the first way. So let's go back. I prefer to explicitly expose the endpoints that I want to use, so I clearly know which endpoints are exposed by just looking at this list. Here, the web means the endpoints are exposed via HTTP. It turns out there are two supported methods for exposing endpoints, HTTP, like this one, and GMX. GMX stands for Java Management Extensions. HTTP is the more popular method used, so I will not cover GMX. I want to reiterate here that since endpoints may contain sensitive information or sensitive operation, you should carefully consider when to expose them. We'll talk about securing endpoints later on in this video. Okay, not sure if you noticed or not, but Spring Boot automatically restarts once I pressed the Save button. This is due to Spring Boot DevTools. Recall that we added a dependency called Spring Boot DevTools when we first created this project using Spring Boot Initializer. Spring Boot DevTools provides a cool feature called automatic restart for enhanced development experience. Whenever files on the class path change, for example, if you change a property in the application.yml file, or if you change a Java file, Spring Boot DevTools will cause the application to restart. This is actually faster than if you click here to restart, because automatic restart is a hot restart. By having Spring Boot DevTools, we don't have to manually restart the application during development. But remember, when you change the pom.xml, you do have to manually restart the application. Remember that. If you work with IntelliJ, I included some instructions to set up this automatic restart in the description of this video. Take a look. You will love this feature. All right, now let's go to Chrome. So if I refresh, as you can see, this time there are more endpoints. And let's start with the health endpoint. This is probably the most commonly used endpoint in Spring Boot Actuator. this endpoint provides an aggregate status of the application and individual status of external dependencies. However, there is not a lot of information here, right? Just status is up. Pretty boring. By default, the details of this endpoint are not shown. Let's change that. Let's go back to IntelliJ and add more configurations. So come down here. Make sure you don't mess up the indentation. Endpoint, health, show details. By default, it is never, and we're going to change it to always. As you can see, Spring Boot DevTools is automatically restarting the application. Okay, so let's go to Chrome and refresh. Okay, now we have more information here. Since we're in dev profile, we're using H2 database. We also have the health check for disk space. For example, it is up, there's a total space, free space, threshold used, path exists. There's also a ping status, which is up. As you can see, now the health endpoint shows the overall health status and a summary of several health checks or health indicators for its components. You don't have to worry about setting up those. Spring Boot will use auto configuration to set up those health checks. For example, during development, our application uses H2 database. Spring Boot detects the H2 library on the class path and automatically sets up a health check for the H2 database. When we deploy this to the production site, Spring Boot will auto-configure the health checks for MySQL. How convenient. I included a list of auto-configured health checks or health indicators in the description of this video. Take a look. Then, those individual health checks, like in this case, DB, disk space, and pin, will then be aggregated or combined to show if the application as a whole is healthy or unhealthy. If one of those individual health indicators returns status down, the status of the entire application will be down. For information, if the health status shows down, we'll get a 503 service unavailable error code, and I will show that later on. Next, let's add two more health indicators, liveness and readiness health indicators in this endpoint. By default, they are not enabled. This is very useful if you use a container orchestration tool like Kubernetes. So let's go back to IntelliJ and add this property. Probes enabled true. Okay, so let's go back to Chrome and refresh. Now we have more information in the health endpoint. Then what is liveness? What is readiness? The liveness state of an application tells whether its internal state allows it to work correctly or recover by itself if it is currently failing. A broken liveness state means that the application is in a state that it cannot recover from, and the infrastructure should restart the application. While the readiness state of an application tells whether the application is ready to handle traffic. Because during Spring Boot startup, our application may need to perform some initialization using the command line runner before it can handle requests. We use that in the DB data initializer, right? So during that time, the application is live, but not ready. Next, let's define our own custom health check or health indicator and add it to this health endpoint. Let's go to IntelliJ. Let's check the current usable disk space and add that information to the health endpoint. So let's go to Java, and under System, let's create a package called Actuator. Then under Actuator, let's create a new Java class. Let's call this usable memory health indicator. let's make it a Spring Bean by annotating it with add component. So to make it a health indicator, this class needs to implement health indicator, this interface, from boot.actuate.health. Okay, as you can see, it is complaining because we need to implement a method called health right here. All right. Pay attention to the name of this class, usable memory health indicator. So that's the naming convention, like something health indicator. So here's how we compute the usable or available disk space. So first, we're going to have a file from java.io and path, new file, and the current directory. So this is a path used to compute available disk space. Okay, then let's compute path.get usable space. And let's name it disk usable in bytes. All right. Next, we're going to define a Boolean variable called isHealth. So if the disk usable in bytes is greater than or equal to a threshold, for example, 10 times 1024 times 1024, this is 10 megabytes. If this is true, then it's healthy. Then we're going to define a status object. So make sure you know that this status is from the actuate health status. So if its health is true, then it is status.up. If you remember, there's a status up or down. Otherwise, status is down. Okay, so here up means there is enough usable memory. Now, this health method is supposed to return a health object with the appropriate status, such as up or down. So here is, we're going to use a builder pattern, health dot status. We're going to pass in the status we computed in the previous step. We can also attach some details to this health object. Okay, so in this case, we're going to use with detail, not with details, because we're going to add those details one by one. And basically, it's a key value pair. So for example, this is usable memory, and the value is disk usable in bytes. And keep going with detail, threshold, and finally build. As I said before, this is a builder pattern. So if you're familiar with OOP design patterns. So let me make some comments here. In addition to reporting the status, we can attach additional key value details using the with detail key value method. Okay, this one. Okay, Spring Boot will detect this bean we created and add its result to the health endpoint. So let's go to the browser and test. So refresh. All right, as you can see, now in the components, there is one more component called usable memory that I defined. Status is up, details, we have two key value pairs. Next, I'm going to make this status go from up to down. And let's see the ramification. Okay, so let's go back here. And let's increase this to 10000000. So this is super large. Apparently, we don't have this much usable memory, so this is health will be false. If this is false, then status will be status down, and that return status is down. And let's go back here. Let me go to F12 to show the traffic. So here the network, right now is nothing. Then refresh. Okay, as you can see, my usable memory status is down, but everything else is up, like readiness, pin, liveness, and so on and so forth. But the entire application status is down. If you take a look at this request, as you can see, we're getting a 503 service unavailable error code. In this case, the site reliability engineers need to be notified to resolve this issue. Okay, so let's go back and let's change it back to 10. All right. Let me refresh again. Okay, now everything's back up. Another important use case of custom health indicator is that assume that our application depends on the service from another application, maybe another Spring Boot application or .NET application. The health of our application also depends on the health of the other one, right? So we need to perform a health check on the other application periodically. That's all for the health endpoint. Next, let's move on to the info endpoint. The info endpoint displays arbitrary application information. By default, it is empty, so it's pretty boring. Because Spring Boot doesn't know what information the developers want to put here, right? So let's customize it by adding some information to this endpoint. There are several different ways to add custom information to this info endpoint. The easiest way is to define them directly in the application.yml file. So let's go there. Okay, so make sure there's no space here. So info, colon, and we can call this app or application. Either is fine. Let's give our app a name. For example, in this case, it's Hogwarts Artifacts Online. And then next, let's give a description. Copy and paste. Okay, then a version. And right now it's 0.0.1 snapshot. But I don't want to hard code it here. Now recall that we have a version in the pom.xml. So how do we retrieve the version from pom.xml? So here is the syntax. at project.version. Okay, now let's move on. Author is Bing Yang. And I can also define two links here. One is my YouTube channel, paste, and the other one is GitHub link. This is not enough. We need to also enable this endpoints environment info contributor. Here is the syntax. So let's come here. Okay, don't mess up the indentation. Info environment contributor enabled to true. By default, it is false. Okay, so make sure you add line 24 to 26. Otherwise, those information will not be added to the info endpoint. So basically, this property exposes the custom information we defined here in this application.yml file. Don't forget it. All right, then let's go to the browser and refresh. Okay, now we have the basic information about this project here. This may seem very trivial, and the benefit of using this info endpoint may not be obvious in our monolithic Hogwarts Artifacts Online project, but it can be very, very helpful for distributed microservices. Here's why. When building microservices, it is quite typical for a specific team to take ownership or accountability for one or more microservices. Therefore, we can enrich this info endpoint with details like the project's name, the responsible team, and the primary contact. If every microservice provided this information, it would enable the creation of a dashboard displaying the project team and point of contact. Such a dashboard could be invaluable for site reliability engineers, those managing the application's operational aspects in a live setting. Should a problem arise, the site reliability engineers could consult the dashboard to identify the appropriate contact quickly. Who to blame, right? That's just kidding. We need to get the problem solved as soon as possible. Let's come back to IntelliJ. I also want to talk about line 31. We have this @project.version@. The reason this works is that there is a predefined configuration that tells Maven to filter this application.yml file. And here is where you can find that configuration. So let's go to pom.xml, scroll up, and let's click into starter parent, and scroll down. It's right here. Maven will filter application.yml or application.properties. That's why that @project.version@ works. If you need a refresher about this file, I included a link to a video in the upper right corner. Take a look. Let's add more information to this endpoint by enabling some built-in info contributors. First, let's add the Git information in this info endpoint. So let's go to here, Git. So enable is true. And also the mode should be full. Full will give us more information. Again, this is really important if we're developing microservices. This info endpoint can let people who run the operation know what current Git version this service is running on. But this is not enough. We need to add a plugin in the pom.xml. So let's go to pom.xml. Scroll all the way down. That's where we define all the plugins. So right now we have two plugins, Spring Boot Maven plugin and the Maven Surefire plugin. Okay, so after here, let's add in this plugin. It is this git commit ID Maven plugin. And make sure we reload Maven. Now this time, since we changed the pom.xml file, we need to turn off the project. So first, let me delete this. And then here we're going to use the Maven wrapper to start our Spring Boot application. Okay, so don't click this run button. This won't work. So we have to start the application in this way. This will let the plugin generate a git.properties file at the root of the class path. Okay, so it's done. Now let's expand target. All right. Okay, as you can see, this plugin generates a git.properties file at the root of the class path. So let's take a look at here. This file contains information about the state of our Git source code repository when the project was built. And by default, the endpoint exposes git.branch, git.commit.id, and git.commit.time properties if present. That's the simple version. But recall that we want to display the full Git information. That is everything here. So we use the full mode. Okay, then let's go back to Chrome and refresh. Now we have this Git key value pairs. We have a bunch of information here. And as I said, this is very important in microservices because people will know which Git version that this application is running on. Next, let's go back to IntelliJ and add more information to this endpoint. Let's add the build information. Build, enable to true. By default, it is false. And to make this work, we have to add something in pom.xml as well. But this time it's easier. So let's go to Maven plugin right here. And we're going to have executions, execution, and goals. And let's add a goal. I'm not a big fan of XML. And just say build-info. Save. Reload. So after adding this execution goal, Maven will generate a build-info.properties file under meta info on the class path. So let's go to terminal. First, let me shut it down, the previous one. And let's run it again. Okay, so let's go to target. Right, so here under meta-info, we have this build-info.properties. This file contains build information like coordinates, name, and version of the project. All right, then let's go to Chrome, and the actuator will read this build-info properties and show it in the info endpoint. As you can see here, we have an extra key value pair build, and this is the value. Let's go back to Chrome and add 2 more information. Let me turn it off. And here we're going to have Java enable to true and OS enable to true. And let me rearrange this. I like to put this one before. Okay, so this time let's start the project. Okay, so here let's test again. So as you can see, besides Git and build, so here we have the Java version, the vendor, runtime, JVM, and also the information about the operating system. Spring Boot Actuator is collecting those for us automatically, so it's very convenient. Next, let's talk about a very important endpoint, metrics. Metrics? Wow, there are a lot of metrics. The metrics endpoint provides a list of available metric names collected by the actuator. One thing I really like about Spring Boot Actuator is that based on what library or tool is available in the project or on the class path, the actuator will automatically start to collect metrics about that library or tool. For example, we have H2 database on the class path. Guess what? The actuator is collecting metrics about the connection pool, JDBC connections, and so on. We have Spring Data JPA on the class path. The actuator is collecting metrics about that. We also have Spring Security on the class path. It's so conscientious and collecting those metrics for us automatically. Those out-of-the-box metrics are very useful. But here is just a list of metrics. What about their values? We can drill down to view information about a particular metric by providing its name as a selector. For example, let's try to access gvm.memory.max. So copy this. Let me open a new tab. We still have metrics. Just append it to this endpoint. So we want to look at gvm.memory.max under metrics. This metric is about the maximum amount of memory in bytes that can be used for memory management. This setup, here we have the metric names, and in this metric we have those key value pairs or tags, is something called dimensional name. It's very different from the early versions of Spring Boot Actuator. So dimensional name means that there is a metric name like jvm.memory.max and then key value pairs attached to this metric name. It's more organized and readable. Next, let's look at more. We have something called gvm.memory.used. So let's come here. This shows the amount of memory currently used by the JVM. And we can also look at something like JVM classes.loaded to get an idea of the number of classes loaded in the JVM at this moment. As you can see, there are almost 19,000 Java classes loaded in the JVM. We can also look at JVM gc.pause to look at the time spent in garbage collection pause. We can also take a look at the threads. So jvm.threads.live to check the current number of live threads, which is 29. If you wonder how long it takes to start our Spring Boot application, take a look at this metric, application.started.time, to show the time taken for the Spring Boot application to be ready to service requests. So it's 7.56 seconds. I definitely need a new computer. Also, it has metrics about Tomcat, which is our web application server. Tomcat.sessions.active.current. Now this shows the current number of active sessions in Tomcat, okay, which is 0. Recall that in the security configuration class, we explicitly disabled Tomcat sessions. Okay, the next one I think is very useful is spring.data.repository.invocations. Press enter. This metric measures the number of invocations and the timing for each repository method. Now remember, we have 3 repositories: artifact repository, user repository, and wizard repository. Okay, as you can see here. Based on this metric, we have already made 21 repository invocations. Now, let me make another repository invocation to get a list of artifacts. So come down here. Okay, and let's go back to this Spring Data repository invocations. And if I click refresh, can you tell me what is the count? Now remember, this 21 is before I made this request. So after I make this request, now what is the count? You're like, yeah, it is 22 because we just made 1 repository invocation. Okay, let's see. It is 24. This number increases by 3. Why? I only made 1 request to the artifact repository, right? Okay. We're using the browser to test this endpoint. So when we queried the repository or database for a list of artifacts, actually there were 2 queries. First, access the user repository to verify my login status using basic authentication, John and 123456. As you can see here, there is this find by username. The second one is the artifact repository invocation, find all. So there are 2 invocations. And then when we come back here and click this refresh or reload, behind the scenes, Spring Security will verify my login status again using the basic authentication. That's why there are 3 repository invocations. If we used Postman and GWT for this demo, this count would be increased by 1. What if I want to know how many times this find by username is invoked? How do I know that? It turns out that we can add any number of tag equals key value query parameters to the end of this URL. So for example, question mark, tag equals method, colon, find by username. We can use this to dimensionally drill down on a metric. So press enter. All right. This shows that find by username is invoked 17 times. And here is the total time and also what is the maximum time. And we can do the same thing for find all. Okay. As you can see here, find all is only called once. It's this one, find all artifacts. Now, if I change this one to wizards and press enter, okay, and come back here and refresh, it's called twice. But this is really confusing because those are different find alls, right? There is a find all in the artifact repository and the wizard repository, as you can see here. Okay. And let's go back here. And let me show you one more. Tag is equal to repository. And I want to see some information about artifact repository. Here you can see that the methods in this repository get called twice. They are save and findAll. Both invocations are successful. Let me show you another useful metric. It is http.server.requests. So this metric is about the HTTP requests made to the server. There are things like count, total time, and max time. Now, as you can see here, those are the HTTP requests that we made up until now. Spring Boot Actuator provides a built-in mechanism to measure API response time using this metric. It turns out that this metric records the duration of each request received by the Spring Boot application. By analyzing this metric, we can measure the response time of our APIs and identify any performance issues. So for example, we can see the latency of, for example, API v1 wizards. Okay, so let's do that. Now remember, how do we drill down this one? Question mark, tag equal to URI, and then followed by this value, API /v1 /wizards. Okay, press enter. Now here are the detailed metrics about this HTTP request, this API call. So it's called once. Here is the total time. And at this moment, all requests are successful. Once we connect Spring Boot Actuator to a visualization tool, we can generate some traffic to our APIs and see the visualization. We can also export them for further analysis. We'll do that in the next video. Okay, so let's go back here. And let me remind you that Spring Boot Actuator is using Micrometer as its metrics collector. The Micrometer library enables us to use various monitoring or observability tools by providing a simple facade. So facade is also an important OOP design pattern. I included a link to the supported metrics in the description of this video. I strongly encourage you to skim through it. They include things like JVM metrics, system metrics, application startup metrics, logger metrics, Spring MVC metrics, Tomcat metrics, cache metrics, data source metrics, Hibernate, Spring data repository metrics, and so on. This is also a good learning experience. By knowing what we measure, we can build better, right? Well, the built-in Spring metrics are great, but we may also need to create and publish our own custom metrics and add the custom metrics to the metrics endpoint. So here is the idea. I want to define a metric that counts the number of times an artifact is viewed by our customers and users. Recall there is a findById API endpoint, right? That can help us understand which artifact is more popular. So probably we can borrow it from the owner wizard for a magic artifact show over a weekend. So let's do that. Let's go to IntelliJ and let's find that API, which is in artifact controller. To create our own custom metric, first we need to inject a meter registry into this class. Private final meter registry from Micrometer. And we're going to use the constructor to inject it. Okay, good. Think of this meter registry as a data structure that holds various metrics. And we're going to add our own metric into this registry. So when we access the metrics endpoint, it shows everything. Okay, then let's go to find artifact by ID. We're going to create a counter for each artifact that is viewed. And that counter keeps track of the number of times that particular artifact is viewed. And here is the syntax. Meter registry dot counter. Okay. Now, by the way, you can also create other metrics such as gauge, which is very useful for monitoring things with natural upper bounds. For example, you can use a gauge to store the size of a collection or the size of a map or the number of threads in a running state. You can also create a timer to keep track of the start and end time. But in this case, we're going to create a counter. We need to pass a name to this counter. Let's call it artifact.id plus artifact ID. So this ID is the input of this method. So this counter method returns either a new counter or an existing counter. And once we get this counter, in this case, we're going to increment. Now, it is a good idea to place this counter.increment after this.artifactService.find by ID to make sure that this ID is valid. If the input artifact ID is not valid, a 404 will be thrown. We don't really need to increment the counter, right? A quick summary here. We injected a meter registry into this artifact controller class because we want to measure something in this class, and created a metric, which is a counter, with this name, artifact.id. The actual artifact ID passed in by the user. We can then use that counter to record the number of times a particular artifact is viewed. All right, let's go to the browser and test. So if I refresh, and nothing happened because we have not requested any artifact. So let's go to here. Okay, and let's try this ID here. Okay, 1, 2, 3, 4, 5. And then let's view the second one. 2, 3. Okay, so the first artifact is viewed 5 times. The second one is viewed 3 times. Then let's go to the metrics endpoint and refresh. All right, as you can see, our custom metrics are added to this endpoint. Artifact ID, the ID of the first artifact, and also artifact ID, the ID of the second artifact. Now let's drill down. So let me copy this. And let's go to metrics, append it here 5 times. And the second artifact is viewed 3 times. So those are the business level metrics that I mentioned before, is that those data can help us make some business level decisions to better our business. The second custom metric I want to create is about time. So I want to record the time it takes to execute a method in the service layer. Here's what I mean. Now, you don't have to measure the latency in the methods of the controller because those are measured automatically. But Spring Boot Actuator will not measure methods in artifact service. So what if I really want to measure, for example, the latency of findAll in this artifact service? And it's pretty easy. The only thing you need to do is add an annotation called @timed. Okay. And here we're going to give this metric a name as well. Let's call this findAll artifact service.time. This will be the metric name. So let's go to Chrome and let's try to access API v1 artifacts, because we know that if we call this API, that service method findAll will be called. Okay, and we can click multiple times. Okay, now let's go back to the actuator metrics, okay, and refresh. All right, now as you can see here, we have the findAllArtifactsService.time. And we can take a look at this one. So we have executed 5 times, total time, and what is the max time among the 5 requests. Okay, so we spent a lot of time on metrics. Let me close this. All right, let's move on to the next useful endpoint, environment. This endpoint lists the active profiles and various properties of the current Spring Boot application. So those properties are from different property sources. In other words, where they're from, such as the application properties files, system properties, system environment variables, command line arguments, and so on. So for example, those properties are from system properties. Things like java.classPath, java.vendor.url, and so on. Now, those properties are from the environment variables, like the path, Java main class, and so on. Okay, so this one should look familiar. Those properties are from application-dev.yml. Since we're using H2 database, we have a data source URL, username, password, and remember this show-SQL is true. Okay, as you can see here are everything we defined in the application.yml. Now remember we have this one, right? Management, endpoints, web, exposure, include, but the value is hidden. Now there's one more thing I want to talk about here is if you scroll all the way down, and we also have some properties that are provided by DevTools. I really love DevTools. So if you're using H2 database without DevTools, then you have to explicitly set this property to true. But if you add DevTools, then you don't have to worry about it because this property is from DevTools, and by default, this value is true. Okay, right now it's hidden. So that's why the DevTools provide a lot of good defaults for our application. So it's highly recommended. Okay, this environment endpoint is great. But as you can see, by default, the values of all properties are hidden, since they may contain sensitive information. To display those values in this endpoint, we can add this configuration in the application.yml file. Let's go to IntelliJ. From here, environment, always. Then, if you refresh, those values will be shown. This environment endpoint is useful because if you start an application in the production site, you may want to know the properties that this application is using and their values and where they're from. This is a very good endpoint. Let's move on to the next endpoint. The next one I want to show you is localhost actuator beans. This endpoint provides the names of all the Spring beans loaded in the application context. And as you can see here, a lot of beans, they're from Spring Boot itself. But we do have some of our own beans. So for example, artifact controller, like this one. This is a bean that we created, and the scope is singleton. So that's the default scope. Only one instance of the controller is created. And that's the class, the type, the resource, and also dependencies. So this bean depends on artifact service, DTO, converters, and also simple meter registry. So that's the one I just injected. As you can see, here we have more than 500 beans loaded in the application context. All right, let's move on. Now, the next one I want to show you is localhost actuator / configprops. This endpoint displays a list of all the bins annotated by @configuration_properties. This @configuration_properties annotation makes it easy to bind property values defined in property files, such as application.yml or application.properties, to a Java object or to a Spring bin. What does that mean? Let me show you one example. Recall that in our application.yml file, we defined a property called management, endpoints, web, exposure, include. It turns out that when we launch the project, Spring Boot will bind the value of this property to a class called web endpoint properties. So let's take a look at this one. So let me copy the class name and go back to IntelliJ and search for this class. It's right here. Now take a look. This class is annotated by this @configuration_properties, and inside it has a base path, which is /actuator, we know that. And the important thing here is, and it has exposure and include, which is a set of strings. Remember that comma-separated strings. So what's going on here is that this annotation will make that data binding much easier. Okay, so this endpoint shows us that. Here's a small homework. Take a look at the Spring data source property. What is the class that receives its values? By default, the values of all properties here are hidden. To display the values, we can add a show values equal to always, like this. Now you can see all the values here. Okay, next, let's go to heapdump endpoint. It's also very useful. Now, as you can see, it's downloading a file which is over 80 megabytes. This endpoint returns a heap dump file. Heap dumps are very useful for identifying memory-related problems. We can use tools to analyze the heap dumps to find memory leaks, understand how memory is used by an application, and locate the code that uses large amounts of memory resources. Some popular memory analysis tools include Eclipse Memory Analyzer Tool, or MET, Visual VM, and IntelliJ. By the way, you can also perform a thread dump using /actuator/thread dump to analyze the behaviors of the threads. Let's move on to the next one, the httpexchanges endpoint. Now, this one is not working. Why? This one requires an HTTP exchange repository bin. So let's set it up. So let's go to System, Actuator, and right-click. Let's create a new Java class. Call this Actuator configuration. Add configuration. And here we're going to create a bin, define a method that returns a HTTP exchange repository in-memory HTTP repository equals new. Okay. And return this repository. Okay. By default, this repository will hold the last 100 HTTP request response exchanges, but we can always set it to a different value. For example, repository.set capacity to 1000. So if you want to monitor the last 1000 request response exchanges. Okay. So here I'm going to comment it out. Then let's go to Chrome and test this endpoint again. Now, as you can see right now, there's nothing there. Let's make some requests. 1, 2, 3, 4, 5, 6. And then maybe users, wizards. Okay, then come back here and click refresh. Okay, as you can see now we have some requests. And it's pretty detailed. It keeps track of the method, headers, and a bunch of things, response, 200, and time taken, and so on. So this is the last request, wizards. It's a request, a response, and then we have the users and artifacts, and artifacts again, and so on. Okay, so just remember, in order to make HTTP exchanges endpoint to work, we need to create a HTTP exchange repository bin to enable Spring Boot to record and store information about the last 100 or 1000 HTTP exchanges that occur in our application. Okay, now next, I want to show you loggers. So localhost actuator loggers. This endpoint provides access to the application's loggers and the configuration of their levels during runtime. So for example, let's search our application, Hogwarts. As you can see right now, our log level is info, 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 info. And the good thing about this endpoint is that you can change the login level of a running application without restarting it. And this is where you can interact with a running application using Spring Boot Actuator. This means that in a live environment, you have the option to enable detailed debug logging temporarily to collect troubleshooting information and then quickly disable it to prevent the accumulation of excessive log data. So let me demo this to you. We're going to change our logging level from info to debug and then quickly change it back. To demo this, we have to use Postman. To configure a given logger, we need to make a post request to this endpoint with this JSON message. So now I'm going to change the configured level to debug. By the way, here I'm using GWT authentication. So send. Okay, so we got a 204 no content response. It means the server has successfully fulfilled the request and that there's no additional content to send in the response payload body. That's fine. Then let's read it. So let me change this from post to get. Recall that the configure level was info, so send. Now, both the configure level and the effective level are changed to debug for our Hogwarts Artifact Online application, so we can collect some troubleshooting information. Now, what if I want to change it back or reset the specific level of the logger? That is easy. So just change this one to null. And of course, we have to make a post request. So send. Okay, now let's get the value again. Now, as you can see, everything's changed back to info. Okay, so let's go back to Chrome. The last endpoint I want to show you is mappings. The mappings endpoint provides information about the application's request mappings. Recall that in the controllers, we defined many request mappings, such as get mapping, post mapping, update mapping, and delete mapping. It turns out that besides the request mappings that we defined, Spring Boot has a lot of built-in request mappings. For example, here, this is the mapping for actuator metrics, actuator health again, actuator metrics again, and so on. There are a lot of mappings that built in. If I collapse this, there are also a lot of mappings in the servlet filters. And here we can see there are two servlets. One is the dispatcher servlet from Spring MVC, and the other one is the H2 console servlet. Okay, that's a lot, I know. You can already see that right out of the box, how much information you can get just by simply adding that one dependency, Spring Boot Starter Actuator in the pom.xml file. Before we move on to the next topic, I would like to point out something. You know that many endpoints are available for us to monitor and interact with the application because we exposed them in this application.yml file. Well, it turns out that an endpoint is considered to be available when it is both enabled and exposed. You're like, we only exposed them, right? We never enable an endpoint. Are they the same, enabled and exposed? Well, they're different. By default, all endpoints except for shutdown endpoint are enabled. Then what about endpoint exposure? By default, only the health endpoint is exposed over HTTP. You know that part. Beginners often confuse enabling an endpoint and exposing an endpoint. So what's the difference? Enabling an endpoint means that this endpoint is created as a bean and registered with Spring Boot application context. Disabled endpoints are removed entirely from the application context, so enabling is more about an efficiency thing. There are less beans to load. Exposing an endpoint means that this endpoint is remotely accessible either over HTTP or JMX. This is related to security. And here is the syntax to enable or disable an endpoint. So for example, let's try to enable shutdown. By default, this is false. Okay, this is just for demo because I do not want someone to remotely shut down my application in production site. Okay, next. What if you want to implement a custom actuator endpoint? In other words, create your own actuator endpoint. And suppose we want to create an endpoint that shows the number of Spring beans in the application context. So let's create one. Let's go to main Java system. Under actuator, let's create a new Java class. And let's call this custom beans endpoint, because we do not want to confuse with the built-in beans endpoint. Then let's annotate it as a component. And also, more importantly, let's annotate it with endpoint. Okay, and give it ID. Now recall that every endpoint has ID. It's called custom-beans. Okay. Now, in order to get the information about beans, first we need to inject the application context in this class. Okay. Now, make sure you import the right application context because there are two application contexts. One is from Spring Framework, the other one is from Apache. So make sure you import this one. Okay. And then we're going to inject through constructor. So here we're going to define a method called public int bean count. And simply just return this dot application context dot get bean definition count. But this is not enough. We have to annotate this method with @read operation, okay, which is from boot.actuate.endpoint.annotation. Okay, so what does this get bean definition count do? So let's click inside. So this method returns the number of beans defined in the factory, but does not consider any hierarchy this factory may participate in. Okay, so that means the count may not be accurate. If you really want to get an accurate bean count, you probably have to use some recursive algorithm to traverse its parent as well. But for this demo, this is enough. And remember, we have to add it to our exposure list. So it's here. It's called custom beans. Then let's go to the browser and test. Okay, so first let's go to Actuator, okay, and refresh. Now, as you can see, we have the custom bins it's right here. So if I click, it returns 541. 541 bins in the application context. Okay, by the way, there's also a write operation and a delete operation that you can use in an endpoint. In the end, let's secure the endpoints with Spring Security. So let's close all of those and go to Security Configuration. This is our current security configuration. Since many actuator endpoints contain sensitive information, and it is also possible to interact with the application using those endpoints, such as changing the login level. You have seen that. So naturally, we should keep them secure. So rule number 1, don't expose an endpoint for its own sake. If you don't need it, don't expose it. Let's say we do need to expose some endpoints. Let's configure security rules for them. In this demo, we allow everyone to access the health and info endpoints, but only logged in users with an admin role can access the rest of the endpoints. Spring Security provides some convenient request matcher objects that we can use to set this up. So let's do that. As you can see right now, any logged in users can access all the endpoints. So let's change that. So dot request matchers, and here we're going to use endpoint request dot to health and info. So this is okay. Permit all. And then we're going to secure the rest. Endpoint request dot to any endpoint dot excluding health and info dot has authority role admin. That is, only users with admin role can access endpoints, excluding health and info. Health and info are public. And let's test that. Since my Google Chrome caches the basic authentication, John and 1, 2, 3, 4, 5, 6, and John is the user with admin role, let's use Firefox to test this. Okay, so first, let's try to access health and info. Localhost actuator health. That's fine. And then let's change it to info. That's good. And then let's go to, for example, metrics. Now recall that this one is admin. Okay, so it's asking for the basic authentication. So it looks like that works. All right, let's go back to IntelliJ. Spring Boot 3.2 introduces a break and change. It updated the names of the launcher classes. Look at line 13. This jar launcher now has a new binary name or fully qualified name. So that is, after loader, actually we should have a dot launch. Okay, so make sure you go to the Docker file and change this one, line 13, before we commit and push the code to GitHub. As I said, this is a break and change introduced by Spring Boot 3.2. I included a link to the Spring Boot 3.2 release notes pointing to this particular change in the description of this video. Take a look. In a nutshell, the underlying code that supports Spring Boot's uberjar or fatjar loading has been completely rewritten, and Spring Boot no longer needs to support Java 8. So make sure you change this one. Now we're ready to commit and push our code to GitHub. But before that, let's first test locally. everything looks fine. Let's go ahead and commit and push. Git add, git commit, add Spring Boot Actuator to the project, and git push. Copy and paste, git push. All right, good. Now let's go to GitHub. All right, so here let's compare and create a pull request and create a pull request. All right, so let's go to actions. So this triggers a Java CI with Maven.
2,000 years later.
All right, good, it's done. So let's go to the pull requests. And it's time to merge pull request. But before we do that, let's go to the Azure portal to set up something first. Okay, so first let's go to the staging site. If you recall that when we push the container images, we're going to push it to this staging instead of the production site. But we need to set some configurations here. Okay, as you can see now, the application settings are empty because during the last swap, the settings we set for the staging site get swapped to the production site. So now here is empty. Now we need those. Recall that we need two settings. So one is Azure Key Vault endpoint. And the value here is this one. Okay. And the second one is Spring Profiles active. And the value here is prod. Click OK. Click Save. Don't forget to save it. All right, then let's go back here. Merge pull request.
$2,000 years later.
Okay, so both the build and deploy are successful. So let's go to the staging site. Overview. Okay, browse. Okay, finally, it is deployed. Okay, so let's cancel that and try to access actuator/health. Good. As you can see now, our database is MySQL. Let's access info. As you can see here, we have the information here. And if we access metrics, now it's asking us to log in. So we can type John and the password. Okay, never. Then we can access all those metrics. Okay, so it seems like everything is fine. So this deployment is successful. Next, let's do a swap. Deployment slots. And let's do a swap. Okay, everything's okay. Swap.
2,000 years later.
Great! Successfully completed swap between slot staging and slot production. We're done. So let me close this. Just test one or two endpoints here. Let's go here, do a simple test. health. Okay, so it's working. Let's go back to IntelliJ and synchronize the local main branch. Git switch to main and git pull. All right. Okay, then the local main branch is synchronized with the remote main branch. Let's do a summary here. In this video, we covered various endpoints that come with Spring Boot Actuator. They help the developers and the site reliability engineers gain insight into the running application in production. They also enable the development team to make data-informed decisions on the future direction of the application. Just remember, you cannot build or manage what you cannot measure. The endpoints provided by Spring Boot Actuator are useful. However, using them through a browser or Postman is not fun. Site reliability engineers require advanced monitoring solutions capable of tracking metrics over time, constructing sophisticated queries using tags, triggering alerts based on specific alerting rules, and moreover, offering intuitive data visualization and dashboards. Spring Boot Actuator collects many metrics and tracing information. In the next video, we will first visualize those metrics using Prometheus and Grafana, and then visualize the tracing information in Zipkin. You will also learn how to create email alerts in Grafana. See you there.